Okay, so let's start with today's discussion. So the first question for today's contest was like you've been given an integer sequence of length n, and there are two integers k and x. So basically, you have to make another sequence b, where it will be the same as a, but it will just have an integer x immediately after the kth element. So suppose I have a sequence like ai a2 dot a. So after the kth element, I have to basically insert this x. So one thing I can do is that I basically like print all the elements from 0 to k minus 1. So it would be like a of I to a of k, and then I print this x, and then I will just print the rest of the part from here, from a of k plus 1 to a of n. Note that this is basically one base indexing. In this part, I'm considering one base indexing. So this is basically the logic for this question. So let's go to the code. So I've taken three inputs and an array, and in this new array, basically what I've done is I've taken all the integers from 0 to k minus 1 and post it into the vector. Then I post the value x inside this vector, and then from I equals to k to n minus 1, I basically post all the values which are present in the A, and then I basically print this uh, second array. So this is basically the first question, and I guess like it would not be any difficult one because like it's a simple question. So let's proceed to the next one. So in this next question, we've been said that there is a cuboid which is basically consisting of a diagonal. One point of the diagonal is ABC, and the other point is DEF. And we have been given two cuboids. Now we have to determine whether they overlap or not, like whether the intersection is a positive volume or not. Like uh, suppose I have a cuboid like this, and another cuboid like this. So basically, I have to find out whether this outer cuboid is basically intersecting this cuboid or not. So for doing this, I've been given a set of coordinates like A, B, C, D, and F for one particular cuboid. Similarly, I got G, H, I, J, K, L for the second set of cuboid. So now, like, in order to see, like, for solving this question, you have to understand one concept. Like, when does two line segment will basically intersect each other? Like, suppose I have a range from A to D, another range from B to J. Suppose. Now, when can I say that these two ranges are basically intersecting each other? When the minimum of this particular range is lesser than the maximum of this particular range, then only I can say that okay, this range is basically intersecting this one. Similarly, I can say that the minimum of this range, if it lies between B and J, so in that case, I can say that this range is basically intersecting this one, like for example, like this A and D. Now this B and J, like whatever the minimum will be, like in this case the B is minimum. So this B should always be lying in this range, somewhere between A and D. So I can say that the max of A and D, sorry, should be greater than the minimum of B and J. So this is what should my approach be. Like in that case only, I can say that this B, if it lies between A and D, then only I can say that A and D and B and J basically intersecting each other. So for this question also, we need to go for a similar approach. So if suppose there are three set of coordinates, x coordinate, y coordinate, and j coordinate. So we need to check whether this condition is satisfied for all the three coordinates or not. So for the x coordinate, suppose this one for first cuboid, suppose the range is a1 d1, and for the second cuboid the range is a2 and d2. So only I can say that this condition is satisfied in the x coordinate only if the maximum of these two is greater than the minimum of these two. Then only I can say that okay, that this particular range are overlapping each other. Similarly, if one range is suppose B1 and E1, suppose, and this range is B2 and E2. So these two ranges will overlap only if the maximum of these two range is greater than the minimum of this two range. So this is how we can just find out for the Z also. So when these three conditions will be satisfied, then I can clearly say that these two cuboid will basically overlap each other. Okay. So this is what the logic is. So let's go to the code. So I've taken a set of inputs like A1, B1, C1, D1, and so on. Like so, I find out the maximum of A1 and A2, just like what I've shown right now, and I figured out what it is less than minimum of D1 and D2 or not. Similarly, all the same conditions for all this. Now, if this condition is satisfied, then I will say yes. I will say no. Okay. So, like, do anyone have any doubt in this question? So, like, if not, then I can like stop sharing my screen. The next question will be taken by Prathamesh.
Hello, am I audible to everyone? I'll share my screen just a minute. Is my screen visible to all? I'll so we'll start with the third question. The third question is pretty simple actually. We have been asked that we have a sequence A and we have been asked to remove k elements in any order such that the remaining sequence, like if there are n elements, there will be n minus k elements. The difference between the maximum and the minimum of the remaining sequence is the minimum that we can make, like it's small as possible. So our task is to minimize this difference. So how can we approach this question? So as you can see for the constraints is 2 into 10 to the power 5. So you can, if we go for an n of n square approach or something like that, we'll get a TLE. Because then our, in worst case, our number of iterations will be around 10 to the power 10. So we need to be faster than this, right? So how can we implement this? We have been asked that we can like delete these k elements in any order. So that is not an issue. So since we can delete these k elements, we can simplify our task by sorting. So what we'll do is for our sequence A, we'll just sort it. Okay. And then for we'll make a window, like if this is like the whole sequence, we'll make a window of size n minus k, and we'll move it. How do we check if it's how do we check the difference for each window? Because we have already sorted our whole sequence, we just have to check the last element of this window. Like if this is my window, like this is the last element of my window, and this is the first, I'll just take the difference. Okay, so that's all we have to do. We'll sort it, and then we'll like run this window from this I equal to 0 till some k. Okay, till let k be here, somewhere here. So what we'll have to do, we just run a loop for I equal to 0 to k, and you just uh, check if the like difference is equals to minimum of this difference, like let it remain difference, and like something like a of n plus I, because for we are checking for each window starting from I, n minus k minus 1, something like this, minus a of I. We just have to check this one and we'll get our final answer. We have checked all the possible subsequent like possibilities of size n minus k that will give us like a minimum difference. And what about the time complexity? The time complexity for sorting is O of n log n. Okay. And this one, how much do you think? It will be something like O of k. That's all we have to do. This is like, this will definitely easily pass our gain constraints. So this will be basically, I think, do I have the code? No, no. Okay. So Let me check. As you can see, I've taken this answer as long max because I've taken all my variables as long. You can also write int max because the constraint is 2 into 10 to the power 5. I'll just run my loop. I'll check for this as we discussed, and then I'll just print my answer. That is all you have to do. For number D, there is some concept of bit masking that you can use. You can like check this constraint. It is like 2 to the power 14. It will like pass. So that is something that you can like go through later. So that is all for today's session. I hope you guys understood all the questions that were discussed today, and definitely try question number D. If you have any doubt, we can discuss it in the groups or like mentorship groups. Feel free to ask your questions there. We'll be ending today's session for now. Thank you.